In this session, we are going to solve HackerRank problem flipping bits. Here is the problem shape. You'll be given a list of 32-bit unsigned integers. Flip all the bits. It's basically turn 1 to 0 and 0 to 1. Flip is as good as toggle. And return the result as an unsigned integer. If n equal to 9 to base 10, it means 1001 in base 2. In binary, it is basically 1001. We are working with 32 bits. So the extended LSB is going to be zeros and then followed by 1001 base. So when we are looking to flip, we turn all zeros to 1 and turn all ones to 0. And the resultant value here will be like, it's something like 4294, a huge number. And we are going to return that value. Function description. Complete the flipping this function in the editor build. So we need to implement this. It passes a input integer and returns unsigned decimal integer after flipping. Input format dictates the way in which the input is passed. Is simply going to scan input queries Q as the first line, and each of the next line is going to be n number that is required to be processed. Constraints. The numbers can be between 0 and 2 power 32, and the total numbers will be between 1 and 100. Sample and if we're going to pass three numbers, it's going to be 3 first and then three specific numbers that needs to be flipped. So when this number is flipped, it's going to be like this. When 1 is flipped, it's going to be like this. And when 0 is flipped, it's going to be. Explanation. Take 1 for example, an unsigned 32-bit integer. So it's going to be 1. And flipping so, we are going to get all of this. The 1 and the last one is going to be 0, which is in base 10 value. This. With this background, let us go ahead and implement it. So now before we jump into code, we'll take a visual walkthrough. Consider an input 9 to base 10 as 1001 in binary. An extended format of 1001 in 32-bit integer looks like this. That's going to be the input. We are going to make use of the XOR functionality, wherein XOR of two similar number is going to be 0 and XOR of two different number is going to be 1. So we are going to have a variable mask that is going to be 111 for 32-bit. We are going to XOR the input number with the mask and get the resultant value. As you see here, 1 with 1 XOR is 0, 0, 1 is 1, 0, 1 is again 1, 1, 1 is 0, and 0, 1 is 1. All of this turns to be 1. As a result, you see every bit in the input has been flipped. So all of these zeros have been converted to 1. All of the ones have been converted to 0 with this implementation. Or let's go ahead and implement it in our code. So let us focus into our code flipping. Flipping function passes integer n in unsigned int 32-bit integers as you see here, but here the declaration is int 64. Let us change this. Unsigned int 32 and it returns unsigned int 32 itself. Unsigned int 32. So let us see where this is called in main. So here it's been called. So unsigned int 32. Okay. Now we will implement it. So we know from our visual walkthrough that we are going to make use of a mask. So let us create a mask of all ones in 32 bits. So that's going to be mask XOR 0 unsigned in 32. Let me typecast it 0. And this mask we will XOR with the input. So result colon equal to n with mask, and we return the result. So this is XOR the input with mask for flipping. That's it. So we have changed the type here to unset in 32. And according to the definition of the problem statement, it should work. Let's see. Yes. So there's been a error in the function signature provided by HackerRank, and we have fixed it accordingly. So all the three test cases are passing, and hopefully when we submit, additional test cases also pass through. Let me do it right away. Yeah, 11 test cases, all of them passing through. That's it. We have implemented flipping bits.